Okay, so we're going to start talking about piecewise functions. Piecewise functions. P-I-E-C-E-W-I-S-C functions. All right, piecewise. Piecewise functions. Now, um, basically what you're going to see is that when we graph these, or when you look at a piecewise function, for the most part, they're in pieces. And we looked at one before. If you recall the last class period, see this one right here? That's a piecewise function. So you have this little piece here, you have this piece here, and you have this piece here. So we did look at a piecewise function. We didn't call it a piecewise function at that time. But this is a piecewise function. We're going to graph these in a little while. We're going to graph these kinds of functions in a little while. Okay, so before we start graphing these piecewise functions, we need to talk about how to evaluate these kinds of functions. So here's the first one. So we're gonna evaluate these piecewise functions. All right, so number one. Now, a piecewise function will look like this. It will be f of x equal, and you can have this set, this brace, and you can have more than one function making up this function. In this case, we're only going to look at two, and they're going to be linear. So the first one is f of x equal 2x plus 7 if x is less than 0, and we explain what that means. And then the other part of this function, the other piece of this function will be 3x minus 1 if x is greater than or equal to 0. All right, so we have this function, and this function is made up of two parts. So this function will be 2x plus 7 if the x's are less than 0. Now remember, when we talk about x coordinates, is that your domain or range? Domain. All right, so this part here would be your domain part. So if the x value is less than 0, then that says I have to use this part of my function. If my x value is greater than or equal to 0, then I have to use this part of the function. Okay? So you'll be graphing this piece, and then you'll be graphing this piece in a little while. But for right now, let's evaluate these functions. So let's say I want to find f of 3. So I want to find f of 3. Now it matters which part I use. What is the x value I want to evaluate this function at? 3. So which part of my domain is 3 located? The top one or the bottom one? The bottom one. Right? Because x is 3. Is 3 less than 0? No. 3 is what? Greater than or equal to 0. So to find f of 3, I'm going to have to use the bottom part of my function. So wherever we see the variable x, we use substitute 3. So you can say 3 times 3 minus 1, which is 9 minus 1, which is 8. So f of 3 equals what? 8. So if I were to graph this, remember what that means. That means when x is 3, what's my y value? 8. That's what that means. All right, the next one. Suppose you want to find f of negative 1. All right, I'm sorry, 0, excuse me. I was looking at the wrong one. F of 0, f of 0. So if I want to find f of 0, which part of my two functions has 0 in its domain? The bottom one. Why the bottom one? Because the equal sign. So if you look at the top one, is 0 less than 0? No, 0 what? Equals 0. So I have to use the bottom one with that one as well. So you're going to say f of 0 is 3 times 0 minus 1, which is 0 minus 1, which is what? Negative 1. So f of 0 is equal to what? Negative 1. Again, that means that when x is 0, what's my y value? negative 1. And when we graph these, you're going to have to use that point, 0, negative 1, as part of your graph. The next one, let's suppose you want to find, let me go ahead and turn this off. All right, let's suppose you want to find f of negative 2. Which part of my domain has negative 2 in it? The top one, not the bottom one, because negative 2 is not greater than or equal to 0. Negative 2 is what? Less than 0. So I have to use the top function. So I get 2 times negative 2 plus 7. So that's negative 4 plus 7, which is 3. So f of negative 2 equals 3. All right. So that's the idea of piecewise functions, evaluating piecewise functions and then graphing piecewise functions. Okay, number 2. Let's suppose we had this one. So the only kind of functions, piecewise functions we'll be dealing with will be linear. There are other kinds like quadratic, cubic, things like that, but we're just dealing with linear in this course. All right, let's suppose that f of x is this piecewise function, x plus 5, if x is greater than negative 1, and then 2x minus 1 if x is less than or equal to negative 1. All right, so again, it matters when you evaluate this function, when you graph them, it matters what part of your domain you're using. So I'm going to use the top function if my x's are what? Greater than negative 1. I'll use the bottom one if my x's are less than or equal to negative 1. All right, let's find f of 0. Which function do I use? Which part of the function do I use if I want to find f of 0? The bottom or the top one? The top one, right? Because 0 is greater than negative 1. Is 0 less than or equal to negative 1? No, remember, all negative numbers are less than 0, correct? So you have to use the top one. So we get 0 plus 5, which is what? 5. So f of 0 equals 5. Let's find f of negative 1. Which part of the function do I use if I want to find f of negative 1? The bottom, because that's the one where negative 1 is less than or equal to negative 1. So I get 2 times negative 1 minus 1, negative 2 minus 1, which is negative 3. So f of negative 1 equals negative 3. And then let's find f of negative 3. Which part of the function do I use if I want to find f of negative 3? Top or bottom? Just say top or bottom. Bottom. So that will be 2 times negative 3 minus 1, negative 6 minus 1, which is negative 7. So f of negative 3 equals negative 7. So again, what that means is that when your x value is negative 3, your y value is negative 7. That would be the point that you would plot. Number 3. So evaluating these piecewise functions is not that difficult. It's one of the easier things you've done in here. Number 3, suppose we had this one. H of x equals x plus 6 if x is less than 2, and negative in parentheses x plus 5 if x is greater than or equal to 2. So you want to find f of 2. So which function do I use? Which part of the function do I use if I want to find f of 2? Sorry, that should be not f of 2, but what? H of 2. Thank you. H. The bottom one, because 2 is greater than or equal to 2. 2 is not less than 2. 2 is greater than or equal to 2. So just write out what you see. So where we see the variable x, you're going to substitute 2. So I get negative in parentheses 2 plus 5. And what's 2 plus 5? So that becomes what? Negative 7. So h of 2 equals negative 7. Okay, next one. H of 3. Which part of the function do I use if I want to find h of 3? The bottom, right? Because 3 is greater than or equal to 3. 3 is not less, 3 is greater than or equal to 2. 3 is not less than 2. So you're going to say negative in parentheses 3 plus 5. So it becomes a negative what? 8. So h of 3 equals negative 8. H of negative 4. Which part of the function do I use? That should not be rocket science here. Top one, right? Negative 4 is less than 2. So use the top function. So where we see the variable x, what do you substitute? Negative 4. So get negative 4 plus 6. So that's 2. So h of negative 4 equals 2. So in a little while when we plot these, when x is negative 4, you're going to get the y value to be 2. All right, number 4. Suppose you're told that g of x equals 2x minus 1 if x is greater than 5, 6 if x is less than or equal to 5. So 2x minus 1 if x is greater than 5, 6 if x is less than or equal to 5. And let's suppose we want to find g of 5. G of 5. So you look at your domain part. Where's 5 located? The top or the bottom? The bottom. All right. So in the first 3, where we saw the variable x, and there was a variable x that you actually saw, you substituted that value into it. So I have to use the bottom one, right? But you don't see the variable x. So that means that g of x is always going to equal what? 6. So g of 5 equals what? 6. There's your answer. Suppose you want to find g of 0. Which one do you use? Bottom or top? Bottom. So g of 0 is also equal to what? 6. G of negative 3, what does that equal? 6. No matter what number I plug into x, if x is less than or equal to 5, my y value is always going to be what? 6. There's nothing to substitute. That says y is always going to equal 6. Y always equals 6 if x is less than or equal to what? 5. That's what that means. So notice 6 all the way. Now what if I want to find g of 6? Which one do I use? Top one. Now this time I do have to substitute 6 into the variable. So I get 2 times 6 minus 1. So that's 12 minus 1. And so what's g of 6? 11. G of 6 equals 11. What about g of 8? Which one do I use? Top one. You have to substitute, right? Because you have a variable in that top function. So that's 2 times 8 minus 1. 16 minus 1, which is 15. So g of 8 equals 15. All right, number 5. You have k of x equals and x plus 5 if x equals negative 2, 7 if x does not equal negative 2. So x plus 5 if x equals negative 2, 7 if x does not equal negative 2. All right. Let's look at this one. Suppose you want to find k of negative 2. K of negative 2. I use the top one because x is negative 2, right? So if you look at both of these parts of the domain, let's look at the bottom part. This says I use this one if x does not equal negative 2. Well, in this case, x is what? Negative 2. So I can't use this one. In fact, I have to use this one because that's the one that says that x has to equal what? Negative 2. So I go here, and wherever we see the variable x, I substitute negative 2. So I get negative 2 plus 5, which is 3. So k of negative 2 equals 3. Okay? Now, what if I want to find k of 5? Which one do I use? The bottom. Because the bottom, this part of the domain says this. I use the bottom function if x does not equal negative 2. Well, my x value here is 5. Does 5 equal negative 2 or does not equal negative 2? Does 5 equal negative 2 or does not equal negative 2? Does not. So I have to use the bottom one. Now, based on what we just did, this says my y value always equals what? 7 if x does not equal negative 2. So what do you think k of 5 is? 7. What do you think k of negative 7 is? 7. What do you think k of 4 is? 7. In fact, the only value for x you're going to substitute into the top equation is if x equals what? Negative 2. Every other value for x, you're going to use which part of the function? The bottom. Okay? All right, number 6. H of x equals 2x minus 1 if x equals 3, x plus 5 if x does not equal 3. All right, so let's find h of 3. Which one do I use? Top one, because that says x is equal to 3. So I get 2 times 3 minus 1. So that's 6 minus 1, which is what? 5. So h of 3 equals 5. Now, if you look at that domain, this says that I use the top one only if x was what? 3. So anything else, I have to use which one? The bottom one. So in other words, if I want to find h of 7, I have to use which one? Bottom. I can't use the top one because that says that I can only use it if x is what? 3. So I've got to use the bottom one. So that's going to be 7 plus 5, which is what? 12. So h of 7 equals what? 12. What is h of negative 2? Which one do I use? Bottom. So I get negative 2 plus 5, which is 3. So h of negative 2 equals 3. All right, so that's the idea with those. Now let's do one more with this. So let's say that my function is this, x squared minus 9 divided by x plus 3 if x equals negative 3, and then 7 if x does not equal negative 3. I'm sorry, if x equals negative 3. So the top one does not equal, the bottom one equals. All right, let's find f of 3. Let's do that one first. Which one do I use? I didn't mean negative 3. Let's do negative 3. I'm sorry. Negative 3. Negative 3. F of negative 3. Which one do I use? The bottom. So that says that the bottom function says that y always equals what? 7. There's nothing to substitute. Y always equals what? 7. So f of negative 3 equals 7. What about f of 3? Which one do I use? Top one. Because that says I use the top function if x does not equal negative 3. Well, x here is 3. It does not equal negative 3. So I'm going to get this fraction. I'm going to get x squared. So x is 3, right? What's 3 squared? 9 minus 9? 0. The denominator is x plus 3. So that's 3 plus 3, which is 6. What's 0 divided by 6? 0. So you're going to make sure you write a 0. So you can say f of 3 equals 0. What about f of 5? Which one do you use? Top one. All right, so I use a top function. What's 5 squared? What's 25 minus 9?
16.
Okay, 16. 5 plus 3? What's 16 divided by 8? 2. So f of 5 equals 2. All right, let's suppose I want to find f of negative 4. F of negative 4. Which one do I use? All right, now what's a negative 4 squared? Positive 16. Negative 4 times a negative 4 is a positive 16, not a negative 16. What's 16 subtract 9? 16 subtract 9, 7, okay? And then the denominator, we were using 5, is that correct? No, negative 4. What's negative 4 plus 3? So it's 7 divided by negative 1. So f of negative 4 equals negative 7. All right? Okay, so that's evaluating piecewise functions. You could use that idea when we start graphing these piecewise functions. Okay? All right, so that takes care of that part.